Hi everyone, Miss Kilroy here. Today we are going to do our force and acceleration notes. So go ahead and open up Notability, and I want you to write down what I'm writing down. So we're going to start with the title, Force and Acceleration Notes, and our central question is, how does force affect acceleration? So we should be able to answer this by the end of the video. Just a reminder, if I'm ever going too fast, you can pause the video and get caught up. All right, let's start with what is a force. A force is a push or a pull. So for example, when you kick a soccer ball, you're applying a force. You're pushing it somewhere. You're causing it to move. Or when you're doing a pull-up, you are pulling down on the bar, causing you to go up. So force is a push or a pull, and it causes something to move. Force is measured in newtons, and newtons is a new unit for us, but 1 newton is equal to 0.22 pounds. So the force of 1 newton is about the size of a small apple. So that's about the weight of it. And we measure force using a spring scale. So you can see over there on the right how it has a hook, so we can hook things to it, and the spring will be stretched, and it'll tell us how much force is applied. So force is measured in newtons. 1 newton is less than half a pound, 0.22, and it's measured, use a spring scale to measure it. So for example, here you can see that we hook something on there, and then that is being pulled so we can measure the force there. Okay, so there's a bunch of different types of forces. I want you to write this down. You do not need to write the picture or draw the picture, just write down, maybe put some notes what it is. So the first kind of force is compression. So for example, when you stomp on a can, you're applying a force downward and it's against the ground, so you're smushing that, so you're compressing that can. So compression is a type of force when the two forces go together. Then we have tension. This way the forces are going the opposite way, so people are fighting over something. Something's being pulled in opposite directions. So there's tension there in that rope. Gravity. Gravity is a downward force pulling things down. So when you drop something and it falls to the ground, people say, oh, that's gravity pulling it down. Then we have this force called the normal force, where we've got gravity pulling down on Sully the cat, and the normal force here, the thing that's holding the cat up, is the normal force. So this is when an object isn't moving, so the cat's not going up or down. So it's opposite to the gravity. So the normal force keeps something up. It just acts against an object. Friction. You know, friction, when you go on a slip and slide, it causes you to go far and have fun on the slip and slide. So we've got the motion of the person going to the right, and friction always acts against the motion. So when there's a little bit of friction, that means it's more slippery. So by adding soap to a slip and slide, it decreases the friction and makes you go faster. Now if this slip and slide, if you were to do this on asphalt, there would be a lot of friction, a lot of resistance against your motion, and that would hurt, so that wouldn't be fun. It would not be fun to go on a slip and slide with a lot of friction. You want to lower the friction. Buoyancy is when an object is in water. So here we've got the floaty being pulled down by gravity, as gravity acts on every object, and buoyancy acts against gravity in water, and it's causing it to float up. So this floaty has a lot of buoyancy, and so it's just floating on top of the water. Okay, let's talk about force diagrams. When we're drawing force diagrams, we're not going to draw the object, we're going to draw a dot as the object. So here our dot is the textbook, and we're drawing all the forces acting on the object. So we've got gravity downwards, because gravity acts on all objects on Earth. And then we've got the normal force holding it up. These two arrows are the same size because the object is not moving, so they can just cancel each other out. If one was bigger than the other, that would tell us which direction the object is going. So if we were to remove that normal force, all we would have is gravity downwards and causing the object to fall down. So over on this one, the forces are balanced. They are equal. So the object is not moving. Here, the object, it is unbalanced forces, so it's causing the object to move. Here we've got a whole bunch of forces acting on the object. So if a person throws a bowling ball, we've got the force from the person throwing the ball and friction acting against it. We've got gravity pulling down the ball and the normal force holding it up. So if we notice, our gravity and our normal force are equal, so they are balanced forces, and that means the object is not moving up or down. If we look at the friction and the force from the person throwing the ball, these are unbalanced forces, and we can tell because one arrow is bigger than the other. When the forces are unbalanced, it means the object is moving. Another example, so if we were to apply numbers to this example, we've got the dog pulling the wagon to the right with a force of 12 newtons, and we've got friction acting against the dog, and it's 3 newtons. So to get a final answer, since these are unbalanced forces in opposite directions, we are going to subtract. So 12 minus 3 gives us 9 newtons. But we need to know which way is it going. So because this number is bigger, it's going to be going to the right. So the dog is pulling the wagon with a force of 9 newtons to the right. Now, if you had 2 people pulling a wagon, so you've got the boy pulling with 8 newtons and the girl pushing with 6 newtons, so they're both going in the same direction. They both want the cart to move to the right. So because we're having 2 forces applied in the same way, we're going to add them together. So our answer, our total would be 14 newtons, and it would be to the right, because they both want it to move to the right. Force and acceleration. When a force is applied to an object, the object accelerates. So whenever something is pushed or pulled, the speed changes. So for example, when you push the gas pedal, the car speeds up. So we're going from 0 to 60 miles per hour, and the car is accelerating. So the definition of acceleration is the change in velocity over time. And there's 3 ways to accelerate. We can speed up, like we're getting on the freeway, we're accelerating. Or even when we're changing our speed and we're slowing down. So this is also called acceleration. And then since velocity has to do with direction, if we change our direction, that is accelerating as well. So there's 3 ways to change acceleration. So speed up, slow down, or change direction. So going from straight to right. And that's it. Good luck.